10.2 Hyperbolas. All right, so in the last section, we talked about the 4 different types of conic sections, and in particular, we focused on ellipses. So this time, right, we talked about ellipses. You've talked about circles before. Parabolas are a different issue for a different time. Hyperbolas are what we're going to talk about today. So these are the conic sections formed when you have a plane, or you could think of this as a piece of paper that comes straight down here, and you get two little U's. They actually look like 2 different parabolas that are facing in different directions. So let's go ahead and talk a little bit more about them. Just like with ellipses, this is on the PDF document that I have on Canvas. I really suggest that you print it out. You're going to want this for reference during exams and quizzes and homework. So there's a few things that you need to know about hyperbolas. 1, there's 2 different versions. There's this version over here that opens to the left and to the right, and then there's this version over here that opens up and down. Unlike with ellipses, A does not need to be bigger than B, and I'll make a note of that up here. Not necessarily. Bigger than B. Unlike the way it was with ellipses. With ellipses, you decided your A value based on which one was the bigger number, and that determined the shape of the ellipse. With hyperbolas, you have 2 different setups. Notice the difference between these two. So A squared is always under the first term, right? A squared's under the first term. And the way that it opens up is determined whether X is first or Y is first. If X is first, it opens up to the left and the right. If Y is first, it's going to open up and down. This is really important. I'll make a note over here as well. Let's talk a little bit more about these pictures and what we're looking at here. So you'll notice that this says horizontal transverse axis and this says vertical transverse axis. The transverse axis is going to be this axis right here that goes through the foci and the vertices and the center. These guys right here are the vertices of the hyperbola. Let's see. So this guy right here, vertex, vertex, and then the pink dots, just like they were with the ellipses, these guys are the foci. So this is a focus, that's a focus, and this guy right here is the center. It's going to be a very similar situation over here. Center, vertex, vertex, focus, and focus. So this transverse axis is the one that goes straight through both the foci and the vertices and the center. If it's horizontal, you're going to get that left and right opening, and if your transverse axis is vertical, you're going to get that up and down opening. The other thing you're going to notice with this picture is that there are these asymptotes. So this little box in here is to help you draw the asymptotes, but the asymptotes themselves are the important part. So these are the asymptotes. So these are hyperbolas. They're going to kind of get close to these asymptotes, but they're never going to touch it in the long term. the other difference between hyperbolas and ellipses are what A, B, and C represent. They're not huge changes. So for instance, this distance right here between the vertex and the center is A, just like it was in the ellipse scenario. So you don't have to think about something different there. A is still the difference between the space between the vertex and the center. And C is no different in that C is the distance between the focus and the center. So A is the distance between the vertex and the center. C is the difference between the focus and the center. And then B is what you use to form this little box that you use to draw in the asymptotes. That'll make a little bit more sense as we get closer to it. The last thing to kind of mention here is that you have a new c squared formula. It's not a squared minus b squared anymore. It's going to be c squared equals a squared plus b squared, which means if you wanted to solve for c, c would be the square root of a squared plus b squared. So let me make a few notes over here. I'll pause real quick and write a few notes over here. All right, so I wrote down that information I said I was going to write down here. So A is the distance between the vertex and the center. B is going to be the distance between the center and the other side of this box that we'll talk about more. And then C is going to be the distance between the focus and the center, which would be right here. The other thing, I guess, to point out on this paper is we're used to it being H and then K, but in the case where Y is first, you're going to have the K value before the H value, even though the center is still H comma K. So just kind of be careful in the case of the vertical transverse axis. But let's go ahead and do some examples. So let's start with this. We have x squared over 9 minus y squared over 4 is equal to 1. And again, these are available just like with the ellipses. This is a worksheet that is available on Canvas that you can download and print off and work with alongside me. So first things, we have x first. If we have x first, that means we have a horizontal transverse axis. And if we have a horizontal transverse axis, that means that it's going to open up to the left/right. So let me write it right down here. X squared over 9 minus y squared over 4 is equal to 1. Now, like I was saying before, the number that's underneath this first term is always going to be a squared in the case of the hyperbola. So it's not going to be that 9 is a squared because it's bigger than 4. It's because it's underneath the first term here. So a squared is equal to 9 and a is equal to 3. B squared is equal to 4. B is equal to 2. So let's see, we have 3, 2, and then C is equal to the square root of not a squared minus b squared, but a squared plus b squared. So this would be the square root of 9 plus 4, square root of 13. Now, the square root of 13, let's just make a note over here, is approximately 3.6. We're going to plot the foci on here, but because it's a weird number, we're going to have to approximate it. So I thought I'd put it there. All right, so there's nothing that indicates that the center has moved because there's no x minus h or y minus k. So we can assume that the center is at 0, 0. And we know it opens left/right, so it's going to open like this. The vertices, remember, are going to be these spots right here. So we go a units away on the left and right to plot the vertices. So a is 3, so 3 units away here and 3 units away here. So those vertices are -3, 0 and 3, 0. The foci are going to be square root of 13 units away from the center. So they're approximately 3.6 units this way, 3.6 units this way. Yeah, somewhere in there, right? All right, so the next part, or before I get to the next part actually, while I'm thinking about it, I'm going to pause and make a note real quick about how we plotted those vertices. All right, so here's the statement on how we plotted these vertices, and then the foci are similar, but you were using C values instead of using the A value. All right, so looking back at our picture, we have this. We're going to plot these asymptotes next, which means we first have to plot this little rectangle. So for the rectangle, you're going to go 2 units up or down, up/down, so up and down from the center, and then make a rectangle using the vertices and these 2 dots that you're going to plot. So B value is 2. We're going 2 units up from the center, 2 units down from the center. And then we use the vertices, which one is here, and we make a rectangle. We then make the asymptotes by making a diagonal line through the corners of the box. So there we have our asymptotes. Make a little note here about how we got those asymptotes. All right. We have a bit more to fill out here. We just need to draw in the hyperbola for our graph. So we start at the vertex and then we hug the asymptotes going outward. So this isn't going to make like a U shape. It doesn't make this shape here. They hug the asymptotes. Beautiful. There's your beautiful hyperbola. The foci are going to be at negative square root of 13, 0, and square root of 13, 0. The transverse axis was horizontal because x was first. For the asymptotes, going back to our formula sheet here. This right here is the formula for the asymptotes when you have a horizontal transverse axis. Notice that these are both in point slope form. It's just easier to write it that way when you already know the center. So that's why these asymptotes are written this way. And also notice that the numerator of the slope here it's b over a, here it's a over b. The slope is always going to have the square root of the number under y on top. So b is under y here, so b is on top. A is under y here, so a is on top. So if you think of like rise over run, that's kind of how I like to remember which one goes where. So if you just think rise over run, it's the y value and the x value is on the bottom. Or you can look at your formula sheet, of course. So formulas for our asymptotes. Our center is 0, 0, so h is 0, k is 0, and then, let's see. The number under y is the b value this time, so this is going to be plus or minus b over a times x minus h. When you plug in zeros for the k's and the h, and then our b value is 2, our a value is 3, and then we just need an x because x minus 0 would just be x. So our asymptotes are y equals plus or minus 2/3 x. And that's that. Let's go ahead and do another example. So here, if you remember how ellipses worked, when you didn't have a 1 on this side, you had to do some dividing to move forward. And it's going to be the same situation here. We need to have a 1 on the right-hand side. So if I go back here, you'll notice it's a 1 on the right-hand side. So let me rewrite this. 4y squared minus 16x squared is equal to 64. In order to make the 64 into a 1, I would need to divide by 64. So I'm going to divide by 64 on everything. Simplifying, this will be y squared over 16 minus x squared over 4 is equal to 1. Now, in this situation, y is first. So if y is first, that means that we are looking at a vertical transverse axis. Which means that if this is our grid right here, it's going to be opening up and down. Right? The number under the first term, that's always going to be your a squared when we're talking about hyperbolas. So a squared is equal to 16, a is equal to 4. Don't like that arrow. Let's see, b squared is equal to 4, b is equal to 2. And then c is equal to the square root of a squared plus b squared. So this is the square root of 16 plus 4, square root of 20. Let me move this around a little bit. This could be simplified because it's the square root of 20 is the same thing as the square root of 4 times 5, and the square root of 4 is 2. So 2 root 5, which is approximately, pull out your calculator, 4.5-ish. But I will put 2 root 5 over here. Once again, we don't have any information on the center besides it's going to be at 0, 0 because there's no y minus k or x minus h. So our center will be at 0, 0 again. So next is the vertices. They are going to be a units away from the center. Because we have a vertical transverse axis, that means that our vertices will be up and down from the center. So we will go 4 units away from the center up and then 4 units away from the center down and plot our vertices. So 1 at 0, 4 and 1 at 0, -4. The foci are also going to be on that transverse axis. C is approximately 4.5, so they would be approximately 4.5 units this way, 4.5 units this way. The exact value is 2 root 5, or square root 20. So this would be 0, 2 root 5, and 0, -2 root 5. That's the exact value. Now for the rectangle. So B is 2, which means we go in the direction of the opposite of the transverse axis. So if this is the transverse axis, we're going to use the B value to determine the sides of the rectangle going left and right. So 2 units away here, 2 units away on the other side. And then we use the vertices and these points that we've plotted to create a rectangle. Connect the diagonals of the rectangle. Now you have your asymptotes. And then you just make sure when you're drawing your hyperbola that they hug the asymptotes going out. just like that. Now the formula is going to be y minus k for the asymptotes. The formula is y minus k equals plus or minus either a over b or b over a times x minus h. The number underneath the y value is the a value this time. And if you think rise over run, that would mean a goes on top, b goes on bottom. So a over b. You can also look at the formula sheet, but you know, it's fun to memorize things sometimes. H is 0, k is 0. So we have y equals plus or minus, the a value is 4, the b value is 2, and then x minus 0, which doesn't do much. So this would simplify. 4 over 2 is just 2, so plus or minus 2, x. And there you go. So that's fun, but both of these that we've done have had their centers at the origin. So let's go ahead and look at one that doesn't have its center at the origin. So first things first, x is the first term, which means that we have a horizontal transverse axis. So let's make a note. That this means we are opening left and right. To get our center out of here, just like with the ellipses, just make sure that you're looking for the x first and then the y. So this gives us our h. H is equal to 3 because you do the opposite of the sign you see. And then k would be equal to -1 because it says +1 there. So our center is at 3, -1. So there's my center right there. I'm going to rewrite this, and instead of putting no denominator on that x minus 3, I'll just put a 1 there. Minus y plus 1 quantity squared over 4 is equal to 1. Remember, the number underneath the first term is always our a squared. So a squared is 1, which means a is 1. B squared is 4, which means b is 2. This is different than ellipses. A does not have to be bigger than 2. So 1, 2, c is equal to the square root of a squared plus b squared. A squared is 1, b squared is 4. So the square root of 5 is what c is equal to. That's approximately 2.2. I don't know if we'll actually bother plotting the foci on this one, but just in case we do. So transverse axis, which means our foci and most importantly our vertices are going to be left and right of our center. They are going to be a units away from the center. So this guy is the center. 1 unit away on the right, 1 unit away on the left. Those are both my vertices. We can actually write those down right now. So that's 2, -1 and 4, -1. Then let's go ahead and do the rectangle. So to finish the rectangle, we need to have points plotted above and below the center. Those ones are going to be 2 units away from the center. So 2 units up puts you here, 2 units down puts you there. And then we can make the box. After we have the box, or I guess I should say rectangle, we can draw our asymptotes in. Beautiful. We know that the hyperbola opens left and right, so we'll just follow the asymptotes. And there's the graph of our hyperbola. For finding the foci here, since it's a little bit of a weirder situation, this is not a number that we'll easily add to make a coordinate point. We're going to go back to our formula sheet and look at our foci. So our foci are h plus c, comma k, and h minus c, comma k. So our h value was 3. Our c value was the square root of 5. And then our k value was -1. So our two foci here, 3 plus square root 5, comma -1, and 3 minus square root 5, comma -1. The asymptotes have formula y minus k equals plus or minus, the value under y is b this time, so it'll be b over a times x minus h. So k is -1, which means we'll do plus 1 here. b is 2, a is 1, and h is 3. So our asymptotes will be y plus 1 equals plus or minus, 2 over 1 is just 2, so 2 times x minus 3. Now, if you wanted to get a little bit more fancy here, you could distribute this out. So y plus 1 equals 2 times x minus 3, and y plus 1 equals -2 times x minus 3. You could put these into y equals mx plus b form. So subtracting the 1 and distributing the 2 at the same time. So 2x minus 6 minus 1, because I brought the 1 over. Y equals 2x minus 7. Over here, y is equal to, distribute, also subtract the 1, so -2x plus 6 minus 1. Y equals -2x plus 5. So if you wanted to get the y equals mx plus b version, you would just distribute and solve for y there. And that's that. You have a beautiful picture of a hyperbola and you have all the information about it. Let's look at one that looks like this. So we saw this in the ellipse video. This is an equation in general form, and we are going to have to do some completing with the square here. It's going to be a little bit different because we have negatives involved. Notice that there's a negative on the y squared term. That means that it's going to be x squared first, so it'll be like an x squared minus y squared situation. But let's start by grouping the terms together and moving, when I write this right now, I'm going to add the 353 to both sides at the same time as grouping. So we have 16x squared minus 32x plus -9y squared plus 90y is equal to 353. We want to pull out numbers such that we have just an x squared and just a y squared here. So I'm going to pull out this number here. I'm going to pull out the 16 from the first group. When I do that, I'm left with x squared minus 2x. From the next group, I'm going to pull out a -9. Let me use a different color for that. I'm going to pull out a -9 because that's the number on the y squared term. When I do that, I have, what's going on there? Y squared minus 10y. So imagine if you pull a -9 out of 90, you're left with a -10. And if you think about distributing backwards, it should be positive. So -9, -10y. Equals 353. Now is the completing the square part. So we have x squared minus 2x. We take this number here and we divide it in half and then square it. So -1 squared, which is 1. We will add 1 right here. We're going to come back for it on the other side as well. Minus 9y squared minus 10y take this number, divide it in half, and square it. So negative 5 squared, 25. To the other side, we already have the 353. We need to multiply these together and add them, and multiply these together and add them. Now, this is actually going to end up being subtraction in the end because it's a negative times a positive, but that's fine. So we have plus 16 times 1 and plus negative 9 times 25. So 16 x squared minus 2x plus 1 minus 9 y squared minus 10y plus 25 equals, let's put this in our calculator, 353 plus 16 times 1 plus negative 9 times 25. And I get 144. Each of these can now factor. So we have x minus 1 quantity squared, y minus 5 quantity squared equals 144. We need to make the right-hand side equal to 1, so we will divide everything by 144. And simplifying here, 16 goes into 144 9 times, so we have x minus 1 quantity squared over 9, minus 9 goes into 144 16 times, so y minus 5 squared over 16 is equal to 1. Whew. So we did all that work. Here we go. Now we have enough to work with. First things first. We have x first, which means a horizontal transverse axis. Because x first, that means it's opening left and right. So we're going to have this situation again. The a squared term is 9, which makes a equal to 3. B squared is equal to 16. B is equal to 4. So 3, 4. C is equal to the square root of a squared plus b squared. A squared is 9, b squared is 16. This number will come out nicely. So square root of 25 is 5. So C is equal to 5. Excellent. The center is going to be h comma k, so h comes from the x, so h is 1, k is 5. The center is 1 comma 5. Center right here. Horizontal transverse axis means the vertices will be left and right, same with the foci. The vertices should be a units away. So 3 units to the left, 3 units to the right. Those are my vertices. So that's negative 2 comma 5 and 4 comma 5. We then need to plot the rectangle. We use the b value. We're going to go b units up and down. There's our rectangle. Now we make the asymptotes using the diagonals. Beautiful. And then just use the asymptotes to draw the hyperbola. Just like that. This is a great time for us to actually plot the foci because C is a very nice number here. So the foci should be on the transverse axis, so on the same axis as the vertices, and they should be 5 units away from the center. So 3 units, 5 units will put that right there and here. So these are the foci. One of them's at -4,5, and the other one's at 6,5. For the asymptotes, so it's y minus k is 5, equals plus or minus. The value under y was b, so it's going to be b over a, so 4 over 3. X minus h. So just to kind of verify the formula, you could look on the formula page. Y minus k is equal to plus or minus b over a times x minus h. That's the formula I used right here. And if I bring us back to that formula page, it's right here. And that's that for that problem. So worst part, honestly, just completing the square twice. But once you get a hang of that, everything is a lot nicer. So I have 3 more problems. Let's go ahead and we'll start with one more. Find the equation of a hyperbola having foci at -1, -4, and -1, 0, and vertices at -1, -3, and -1, -1. So let's start by plotting stuff. We'll start with the foci. So -1, -4, that would be right here. -1, 0 is right here. The vertices are at -1, -3, and -1, -1. And I'm going to just kind of label what these were. Now, we're not actually being asked to draw this hyperbola. The graph is here to help us along in problem solving, but we just want to find the equation. So the first thing we should notice is that the vertices and foci are vertical, which means we have a vertical transverse axis. Which means a few things for us. It means that y is going to come first. And it's going to mean we open up and down. So, like this. The formula we're looking at is y minus k, quantity squared, over a squared, minus x minus h, quantity squared, over b squared, equal to 1. So we can find the center given the information we have, because the center should be directly in the middle of the foci and the vertices. So directly in the middle would be right here. This should be my center. So the center is at -1, -2. H is equal to -1, K is equal to -2. Be careful when you're plugging them in here. Notice that K comes first, so just be careful. It's not, you don't want to put the -1 there. It's very easy and tempting to want to do that, but you're not going to do that. So we have y plus 2 quantity squared over something minus x plus 1 quantity squared over something is equal to 1. We need to find A and B. And this is all we have. This is the information. We have a center, we have vertices and foci, and that needs to be enough information for us to find both A and B. We do know something about A. We know that A is the distance between the vertices and the center. So this distance right here should be A. That's just 1 unit. So this should be 1 squared underneath here. Nothing about this picture tells us anything about B, but it does tell us information about C. C is the distance between the center and the foci. So the distance between the center and the foci, that's 2 units. So we know A, we know C. that's enough for us to find b, because c squared is equal to a squared plus b squared. So 2 squared is 4, a squared is 1, plus b squared. Subtracting 1 on both sides, b squared is equal to 3. And because it's just b squared that we need under here, we don't need to figure out what actually b is. B is the square root of 3, but we don't need to actually figure it out. We can just put the 3 on under there because that's where b squared goes. So our final formula, not that bad, right? Y plus 2 quantity squared over 1, so I won't really put it over anything, minus x plus 1 quantity squared over 3 is equal to 1. Oop. And there it is. That's that for that problem. So let's go back to that completing the square idea. This is going to be finding the foci of the hyperbola, so we don't need to graph it. We just need to find the foci. And we have this equation right here, which is in general form. I'm going to do the same thing I did before. I'm going to add this constant to both sides. And then I'm going to gather like terms together. Because y squared is the positive term, I'm going to put y squared first. So I have y squared plus 6y minus 9x squared is equal to 27. I'm going to complete the square on the y squared. I don't need to worry about that on x. So y squared plus 6y. Take this number, divide it in half, square it. 3 squared, 9. So adding 9 here. Minus 9x squared is equal to 27. Don't forget to add the 9 here. I don't have to multiply by anything because I didn't pull anything out. Y squared plus 6y plus 9 factors into y plus 3 quantity squared minus 9x squared is equal to 36. To make it a 1 on the right-hand side, I'm dividing everything by 36 on both sides. Simplifying, y plus 3 squared over 36. This is going to be x squared over 4 equal to 1. So we have y first, and that means we have a vertical transverse axis. If we come back to our formula sheet, that means we're working here because y is first. The foci are at h, k plus or minus c. So that's what we're looking for. We're able to get h and k, so k is the number next to y, that's -3. H is going to be 0. So we have h and k. All we need is c, which we can find once we have a and b. So a squared is 36. B squared is 4. C is equal to the square root of a squared plus b squared. So 36 plus 4. This is the square root of 40, which it can be simplified to 2 square root 10. So we didn't actually end up using this graph here. We have all the information now because we have h, k, and c. So we don't have to use this graph at all. So the first point is going to be 0, -3 plus 2 root 10. That's our c value. And the next one is 0, -3 minus 2 square root 10. And there we go, we have the foci. So we don't need to find anything else. There's no reason to go further than that. We have everything we need there. Sometimes the formula sheet can come in really handy because it really limits down what you need to figure out. For my last problem, this one's actually not on the PDF document, so you might need to write this down. This is a harder problem, and it's, I think, deceivingly hard. So find the equation of the hyperbola that has foci at -10, 0 and 10, 0 and asymptotes y equals 7x and y equals -7x. I'm going to start with plotting those foci. Right, so those are my foci. It seems clear to me that the center should be right here at the origin because it needs to be smack dab in the middle of the two. So I feel certain at this point I can say the center is at 0, 0, which means h is 0 and k is 0. So that takes care of that piece. The other piece we're given is the information about the asymptotes, which is deceiving, to say the least. So if we look, we have a horizontal transverse axis, right? So the formula should be x minus h quantity squared over a squared minus, because x comes first with the horizontal transverse axis, y minus k quantity squared over b squared equals 1. Going back to our formula sheet, the formula for asymptotes, y minus k equals plus or minus b over a times x minus h when you have a horizontal transverse axis. So it's deceiving. The y and the h and the k are 0, so this is really y equals plus or minus b over a x. It's tempting to want to say, well, if 7 and negative 7 are b over a, then b has to be 7 and a has to be 1, right? Because if b is 7 and a is 1, then you get plus or minus 7 over 1, which is plus or minus 7. Which is great, but there's other numbers that can divide and get 7 as the result as well. For instance, you could have b be 70 and a be 10. Then you have plus or minus 70 over 10, which is plus or minus 7. So we can't just say that b is 7 and a is 1. That's not necessarily a true statement. However, what we can say is that b over a has to be equal to 7. Oops. B over a needs to be equal to 7. This has to be true. If I multiply both sides by a, I'm going to get b is equal to 7a. We'll come back to this in a moment. So let's look at our picture now. We don't know what A is, we don't know what B is, but we do know this distance between the center and one of the foci. So this is the center, one of the foci. That value is the C value. The C value is the distance between a focus and the center. So C is equal to 10. I know information about C, and I have a formula that uses C. C squared is equal to a squared plus b squared. If I know C, so 10 squared, I don't know anything about A, but B is 7A. So I could put, instead of putting B, I'll put 7A squared. I'm replacing the B in the formula with 7A because I know that A has to be 7, or B has to be 7 times A. And I can simplify here. So 100 equals A squared plus 49A squared. So 100 equals, this will be 50A squared because there's a secret 1 here. We can combine like terms. Dividing both sides by 50. We get 2 is equal to A squared. So this whole thing right here is 2. If I square both sides of this formula, I get B squared is equal to 49A squared. So to figure out what B squared is, 49 times, we know A squared is 2. So 49 times 2 is 98. We have H, we have K, we have A and B, so we are good to write our final formula. So the equation of this hyperbola will be x over 2 minus y over 98 is equal to 1. So just be really careful on problems like this that you don't oversimplify it. Sometimes you can be right, but enough times you'll be wrong to frustrate yourself. Okay, so you have to set this up over here and use that sneaky bit of information you have from the graph to solve for a and b, and you'll be good to go. All right, so this is officially the last video of the class. I am sorry that we didn't get to finish out the class together. I so wish that we could have. I was really enjoying getting to know you guys, and hopefully our futures will come together and we'll meet again. But for now, this is it. I hope you have a fantastic rest of your day, rest of your semester, and I won't catch you in the next video, but maybe I'll see you around. All right, bye.